Welcome to the second and last part of the final episode of Zeroing In, the Science Podcast's first season. I'm Prakhar Agarwal, and hosting this episode with me today is Naman Jain, a recent graduate from the Indian Institute of Space Science and Technology. We are in conversation with one of the highly distinguished Indian scientists and technocrats, Dr. B.N. Suresh. Currently serving as an honorary professor at the ISRO headquarters in Bengaluru, Dr. Suresh is a science and engineering graduate from the Mysore University, and he pursued his post-graduation from the Indian Institute of Technology, Madras in 1969. Following this, he joined ISRO in the same year, and while working there, he earned his doctoral degree in control systems from the Salford University, UK. Dr. Suresh is an internationally renowned aerospace engineer with pioneering accomplishments in the arena of space vehicle design, space navigation, guidance, control and actuation systems, vehicle electronics, integrated simulation for launch vehicles, and on top of that, countrywide R&D management. His role in defining the activities for advanced technology development and their application for space transportation in India has been very significant. And in our conversation with him, we discovered some beautiful insights and perspectives of India's journey in space. So we were talking about the importance of a technology major organization such as ISRO in the context of a developing nation. Indeed, the Indian space program has contributed to India's development in a very significant manner, and it has covered a long journey through the decades. You are one person who has worked with all the generations behind ISRO. It's actually because of your work, along with the work of other luminaries and visionaries, that has brought us to this platform where everybody who's associated with ISRO gets appreciated. So, talking about those visionaries you have mentioned about, like Dr. Vikram Sarabhai, Dr. Kalam, and you've definitely associated with Dr. Satish Dhawan as well. How was it like working with them? And what was their kind of vision which has allowed us to expand and be so effective in the domain of space?
Yeah, I think it's a very interesting question that, as I mentioned earlier, it was Sarabhai who was able to sort of visualize a space program is required. That's why we call him as the founding father. And I want to just give one or two very interesting anecdotes with Sarabhai. When he was there, he started the what we call TELS, Tumba Equatorial Rocket Launching Station. And then, he also believed that we must build a launch vehicle. He came out with a configuration of a four-stage vehicle, which was almost similar to the what we had four-stage rocket Scout in US. That's how we modeled. And that's the reason he thought that we must start Space Science and Technology Center. There was no Vikram Sarabhai Space Center those days. And he used to come in white kurta and white pajama every 45 days once. And there was no director, there was no chiefs. He had put he picked up some 6, 8 people. Went to US, picked them up who are all very bright, willing to come back, brought them and asked them to work in different areas which are needed, like propulsion, manufacturing, control, the aerodynamics, things like that, some 8, 9, 10 divisions, and he formed. As youngsters, for us, it was always a pleasure to attract him to our lab. So I was given development of one of the control systems, and it was within 6 months we were able to put together some 3, 4 of us, and I went to my boss and told, sir, this time when somebody comes, you should bring it to my lab, and because we want to show it to him. It is something like inviting a very big person into our lab, and of course he will come. He came, and then we were all introduced. But he spent, believe me, for half an hour asking several questions, trying to understand. And what amazed me is at the end, whole visit, before going, he shook hands with calling them by name. Each one of them, we were about 6 or 8. Each one of them, he called by name, shook hands, and went. And subsequent to that, of course, this was somewhere in the 70s, somewhere in the middle of 70s, and he died in 71 December. And whenever he comes, he sees me in the corridor of that old building SSTC, and he used to call by name and ask, "How are you? Are you okay? How are things?" This kind of the personal rapport and touch for a person of that caliber and standard. That was Sarabhai. While he sort of seeded the idea, and another thing he did was he brought what you call very, very healthy competitions between people. He allowed people to work on, like permanent development, half a dozen fellows, by controlled development, by half a dozen fellows, because then there is a healthy competition and things will come faster. The which he was able to visualize. Then, of course, Sarabhai's death for a brief, there was MGK Menon, but it was known it was an interim period. Then Satish Dhawan took over. In my opinion, Satish Dhawan is the one who really put the very, very firm foundation, and what we ourselves call ISRO culture today, that is sort of established by him. Many times people ask the question, what is ISRO culture? ISRO culture is essentially, it's just a participatory management. There is nothing like commanded, you do this. That is number one. Number two is anything and everything we do, we have a very, very aggressive debate, discussions, and reviews. Second thing is, and fortunately, he was able to visualize what we term as the unity of command in handling things. I think many of you may know that important positions all rolled into one, and then as chairman ISRO, secretary DOS, secretary the chairman space commission, all in one. That enables for the person who is handling to take decisions. These are all important things which Satish Dhawan did. Then, of course, APJ Abdul Kalam, that he was one always restless. He wants to do new things. That's how the composites took birth. That's how the pyro elements took birth. That's how the basic rocket mechanical engineering took birth. He created so many things, and because of his ability, he was quite junior in the year. But then when Dhawan formed the SLV3 program, picked the Kalam and then put him as the project director. He's like Mercury, he's one person. But at the same time, very humble, he will mix with people. Mind you that he would have walked into my room at least 10 to 15 times during SLV period. He will not call or he will not ask you to come. He will walk into your room. That too mostly it happens at 6 o'clock, 6:30, that's are always scared to go home because boss may come anytime. So, and of course, we were all bachelors those days, and it was easy to spend time all in the early 70s. And, that is the kind of person, and he remained like that, I think, all through his career. Then, of course, the host of other visionaries came, Professor Yora, who created the satellite activity at Bangalore. He is another stalwart, Kastur Rangan. So, we were very lucky to have this kind of visionaries and who guided the activities in a very streamlined and efficient manner. I think these are the reasons we are able to perform so well in the organization in the last 5 decades.
Definitely. There's one thing that is really curious at this point. For instance, about the first launch that Dr. Kalam was heading, and the multiple failures that ISRO had faced, and a lot of national criticism which followed. In that respect, would you like to talk about how you personally dealt with those failures, and how did ISRO at large take care of the sustainability of the space program in the long term?
Honestly speaking, I must say that the failures that we faced in the very initial stages, they were very, very, very frustrating. In fact, we used to get terribly disappointed, and that's where our people who were handling like Sarabhai or Dhawan or Kalam, these are the people he went on encouraging. We have to learn our lessons only through failure, because there is no other shortcut available, because we were not getting any of the inputs available in the literature. You have to build system, do the experimentation, try to see that it succeeds, but by now and then we make mistakes and get into problem. But as time goes, I think we got seasoned. We I told you that two ASLE failures was a very tough job. And the first launch happened, failed. We put a failure on the committee, corrected. And second launch, it is much more frustrating. Everything went into pieces, almost like Diwali crackers. So it was terribly disappointing. And I was telling, we were even shy to say where we are working. But then it took 4 more years for us to churn and then keep on doing lots of analysis, lot of experimentation, lot of simulation, and make sure that everything was here. After 4 years, when we launched the third launch of ASLV, used to call developmental flight, it succeeded. And I want to narrate here one thing. At that time, the third launch when we had Professor Yura was the chairman, and believe me that when the ASLV D3 put the satellite into orbit, for quite some time, he was speechless actually. And the tears started rolling through the eyes. That is the kind of experience that one would have, and all of us felt it. But I think for him, it was very important being head of the institution. I'm sure that he would have taken much more severe brands compared to any one of us. So you can see the difference between the success and failure, and it is so razor thin actually. Anything can happen. Many times I can tell you from our experience, there are instances where it was almost on the verge of failure, but somehow we are able to survive and go ahead. The satellite is put in the orbit, and next day all newspapers flash for the success. But only we, being internally, we know that how close it was that we have succeeded. There are many such instances one can share as the time goes. That is one reason, again, I'll come back to my pet topic of calling it rocket science. It may or may not at any given point of time.
It definitely is enriching and moving to hear about how ISRO dealt with failures and how the technocrats and scientists involved have always paid attention to details, and a mindset of efficient problem solving has always been alive at heart. In that context, in those times, I understand there were a lot of international embargoes, and situations were pretty different for India back then. So, how do you think we started vouching and focusing on indigenization, and how was it like to start working on something from scratch?
Yeah, that is what happened was that I was involved in building the rockets for launch vehicles, and as you know that the rockets are always treated as the dual usage because that can be used for the missiles too. The technology that is needed for missiles and launch vehicles, they are one and the same. So that being so, there is a very strict regime called missile MTC, or missile technology control regime, and that sort of puts embargo or ban on supplying anything which sort of helps to build the rocket, build the launch vehicles. That's a blessing in disguise as far as we are concerned. So we knew that we are not going, although there were government to government level understanding, handshaking, they to express things, yeah, we will supply. But when it comes to the brass tacks of supplying, they never used to give. That sort of encouraged us to take up this development. We have no other way. Number one. Number two is, I think at this point, we should also appreciate the Indian industries. I think that was again Dhawan's visualization. He visualized that unless we bring industry, there is no point in ourselves building in ISRO. It is not going to be a sustainable program. And that's how we joined hands with industry. So today, when we launch PSP, for example, I can tell you almost everything that flies in that, by and large, are all built indigenously. We have gone through very, very difficult phases, very number of failures, but then we all have mastered. So that's one of the very, very important issues. And self-reliance is the one I think we have been practicing from the day one, almost early 70s. What is today coined as the Atmanirbhar. I think we have been practicing in ISRO from the day one, and almost everything that we do, they are all developed within the country, not only indigenized, but I think that indigenous efforts have helped for countries to progress many other domains, not only in space, many other domains because they are available, and that's where the discussion that's going on. Not only we should become supply chain for ourselves, I think we should become the supply chain for the global systems altogether. It means we can enhance the export and then supply. That's what we should be doing in the coming years.
Sure. That is really fascinating to hear and quite insightful at that. At this point, we have a curious query from a student, Aditya Kothari. Aditya, can you please ask your question?
Good morning, sir. I'm Aditya Kothari from St. Xavier School, Jaipur. So my question is that, in your view, how is ISRO so successful in its project, even though it does not get as much resources as other agencies like NASA?
One thing is from the beginning, ISRO is known for carrying out things in a very low cost. Even today, our launches are very competitive and also sort of we carried out our programs in a very streamlined fashion. One another good thing which has happened from the day one is we have what we call short-term vision, mid-term vision, and long-term vision. So, for example, at any given point of time, we know what we are going to do now, what we are going to do likely another 5 years down the line, and 10 years. It may get modified as we go along. But once you have that, we also sort of come out with the action plan of what is the budget that is required, what kind of facilities that you need to develop. And also, we are very good in developing many things at very low cost. Actually, Indians are always famous for. We have our own innovative way of what you call jugaad technology. That is very famous in the country. So I think very judicious development which is happening, and so also our industries also are joining hands. That is number one. Number two is, we are not really venturing into several unwanted areas of work, which possibly many other spacefaring countries would do. So we are very focused on what exactly we should do and how we should accomplish it. That's why every paisa that we spend, it is accounted for and it is being utilized. Not only it is built while building, it not only meets the requirement of that particular project, we also keep what you term as the long-term requirement, sometimes as it is or sometimes with little augmentation, we can use it for the subsequent project. So that way, we are able to sort of utilize facilities that are built for long-term applications. This continuously we keep on doing this. That's how we are able to bring down the cost. And I think that culture continues even today.
Sure. Thanks a lot for your question, Aditya. The next question we have from Shavik Datta. His question is, how do you ensure precision throughout the mission, since a small error in calculation for a few centimeters can be fatal for the mission itself?
Yeah. That requires a very long explanation, but suffice to say that, we need to sort of apply corrections. For example, when we do the moon mission, when we do the Mars mission and all that, error keeps on building and these errors sometimes will take you out of the way. So there are methods using the various other measurements that are possible in the solar system, and you sort of make very precise measurement. For example, based on the star, we can precisely tell where we are, and you sort of apply the correction so that you keep correcting as you go along at different intervals, and then try to do that. Even when we launch our spacecraft into the orbit, there are errors that can happen. So then one thing is you have to have very excellent sensors which have very high accuracy, very low errors. That's where I told you use GPS system on board. So GPS again makes the measurement very precisely, tries to apply the correction then and there, so that you are able to reach the target where you want without any difficulty. So it's called error corrections at different places, and there are several ways of doing it. So how precisely you do that depends. And particularly for Mars mission, for example, you require very high precision, and also how you model your, for example, gravity model what we use for Earth, Moon or Mars, you have to go into very detailed calculation. one decimal error there can cause several kilometers away from the target.
That's quite instructive to know. And coming back to our discussions, I think you were also mentioning about how working on and sustaining the project in ISRO happened. I think that is one of the reasons why ISRO is one of the forerunning uh, leaders for technological developments in our country. So there is a thing I'd like to ask. As you were the director of the Vikram Sarabhai Space Center, or VSSC, there were a number of challenges and collaborative tasks that ISRO was doing, which were, for instance, designing technologies or testing for DRDO and many other technological institutions in the country. So how is that foresight coming along, and how did you plan that this is something that we can do despite having so much work to do already in the organization itself?
Yeah, when we have mastered certain technologies, I strongly believe that we should not work in a shell. I think we should become useful to the country in some form or other. One important example I want to draw is that the light combat aircraft which is there, which is called Tejas today, and I was the member of the test readiness review board, and in the first LCA was being prepared for the maiden launch by the test pilots. They in that particular Tejas, most of the things they have developed indigenously, excepting the two important elements. One is the GE engine, General Electric engines, because we haven't succeeded in developing our own engine in the country. Number two is they use what you call quadruple redundant electro-hydraulic actuators. These are the two major elements. And when this discussion was going on, the nuclear test Pokhran happened. I think it's 1998 or something like that, around that period. I was participating in that review, and the program director, I think all of you know him, Kotari Narayana. He was the program director for that, and test readiness review board chairman was one Air Commander Rajkumar, because they have to fly that. And he came in the meeting, and he said, I have an announcement to make. What it is that because of the Pokhran test, I think this imposed the embargo and asked all people. At that time, our fellows were accepting the final product which is needed for the first flight, the actuators. And they were leave with the pen, pencil, everything, nothing they can take out of the laboratory. And they were all sort of, their tickets were booked, they were sent back. Then, I was there and I told, look, we have been developing several actuators for our own programs and we will do it. So we will put our efforts and work together, and then that what started that way, I want to report here that today it has been successfully developed, gone through all the tests and it has taken about 10 to 12 years, but then I think what ESSC has started, we transferred the technology to Aeronautical Development Agency, and today we become the second country in the world to develop this quadruple redundant electro-hydraulic actuators. They have gone through, and it is sort of being tipped to launch flight very soon. They are waiting because their programs are all well tuned. They have to get an aircraft where they can put and test it. But tremendous amount of water has gone. But in the process, what happened? It's not done by just we alone. We brought in several agencies from industry, from CMTA, from ADA, from ADE, at least about 16 or 18 different departments. We joined hands and took on, and then we moved forward. Similarly, when Kalam took over as the director of DRDL, and he came out with the program of Agni, Prithvi, Nag, Shol, that 5 missiles, called Integrated Guided Missile Development Program, IGMDP. And it was he sort of visualized SLE first stage, I will use as the Agni first stage. And again, we were roped in systems that we had developed. I had developed one of the control systems for that, and we became part of DRDO activity. And then our counseling continued as long as Kalam was in DRDO. So that continued. Like this in several places, we were able to join. And one thing I am impressed upon is Kalam used to tell always, India is like Europe in the sense we have ISRO, we have DAE, we have DRDO, we have CSIR. Each one is one of the very, very powerful and competent organization and technology available, but we rarely sort of join hands with together. If we do, we can do wonders. He believed in that strongly and I also believe strongly. So I keep telling everywhere what we can do. And I got an opportunity, now that Science, Technology and Innovation, STIIP. Recently, they have announced and they are working on that. And Principal Scientific Advisor, DST, and Member Niti Aayog, they are all involved. And I was in one of the committees, and there again, I have propagated this idea. I think let us come out of these barriers and boundaries. I think let us work as one country. We can do wonders. Of course, there are certain difficulties involved, but unless you jump into that, you will never find solutions. I think we should do that. So it's a joy to contribute in this way to many of the programs that are available in the country.
Indeed, sir, that's really nice to know, actually. From our conversations so far, we have realized that you've fulfilled a lot of roles from being a young engineer, designer, and then contributing to various projects in collaboration, and then taking over to review systems and contribute to them in a different manner altogether. On a personal note, how do you see that experience of yours in this entire journey over decades has evolved or changed? Would you like to share something about that?
What I can only share is that every second of my stay, I enjoy doing what I've been doing. I think never look back. There was no moment of frustration, no moment of course, we had failures, we had desperations, but then that's part of life. I think unless we have challenges, life is dull. We must take it squarely and do it. And I always believe that for every problem there is a solution. Question is how you address and how do you get the right solution. And a couple of things I learned out of these reviews and all that. For any given problem, there could be several ways of doing that, but then you have to look all of them comprehensively and then come out with a solution which is feasible, which is doable, which can be carried out within the resources we have. So you have to take that kind of decision so that it works well. And whatever decisions I have made all through this period, I think it all have worked well. And I want to mention one thing is here. This is almost 10 years I've been reviewing since I left IAST till today. And but what is satisfying to me is accepting one launch. I think there are several missions which have happened, including the Mark 3 mission, air breathing, RLV, several new missions, Chandrayaan 1, Chandrayaan, Mangalyaan. Only two places we got into problem. One, I think that 39 of the payload fairing did not open for known reasons. That is one failure we faced. Second is, of course, in Chandrayaan 2, I would call it a failure, but then last minute glitch, we missed having a proper landing. But for that, I think all the decisions that we made, they all have helped to come out successfully in almost all missions, I think. That's a very satisfying experience for me. And I would say I enjoyed much more after retirement rather than being in service.
Yeah, it would have been totally different for you to sit in a chair of review and dissect the work from a totally different approach. Yeah, that's actually interesting to know. Also, sir, you have transitioned from being a scientist engineer working on complex systems and moved on to being an academician, founded and established IST to what it is now. Would you like to share something about this experience?
Yeah, that when I was asked to take over IST, it was a surprise. In fact, I worked for it. I was deeply involved in the setting up of IST and all that till it's approved. And I had very strongly recommended to get a person around 57, 58 age group and put him or her as the director so that, up to 67, 8 years. But one fine day, chairman calls me and told me that nobody else can run it, Suresh, but to take the responsibility. I am appointing you as director. I was quite surprised. But then after I took over, one thing I realized is there is a vast difference being a scientist and being an academician. So you have to totally change your way of working, totally change your way of handling things. What you have done in ISRO or VSSC will not hold good in IAST. I think that is the first lesson I learned, and sort of align myself to their way of thinking, but at the same time utilizing the experience we get in doing things in ISRO. I have to make sort of make some kind of joint program, joint activity which we have. You all have experience. For example, we didn't have the experimentation to do the lab, but then that was the time I thought, why not we convert some of the things which are available in ISRO as our own experiment. It took quite some time, but then we sailed through that. I'm sure that that kind of experimentation we did came quite well. On the hindsight, I feel that whatever activities we did, whatever decisions I made, it all sort of jibed well to reach where we are. So one has to change oneself. That is what is important, actually.
Of course, that's quite relevant to know. And I think all of us thriving at this stage is a very clear example that all that our previous generations have done has amounted to quite a humongous sum and changed so many lives undeniably, and will continue to do so. So we're coming towards the end of our discussion, and there's one interesting question coming from Anurag Sai. Anurag, can you ask your question?
My name is Anurag Sai. I am from Nagarjuna Talent School, Hyderabad. My question is that you have been talked about many strengths, how we have developed our technology in ISRO. But can you talk about things that need to be strengthened, the segments that we need to be strengthened now?
The immediate task, I think, for all people who are working in ISRO, they know that two important areas that they need to master quickly is that for the human space mission, when we talk about putting the human being into the orbit, that requires very high reliability. We call it human rated vehicles. The vehicles, for example, we use GSLV Mark 3. You can't fly what we have been flying to put humans into that. That is one important aspect. It means you need to achieve that very high reliability. How do you do that? It is not a simple task, actually. But at the same time, you can't sacrifice too much on its capability. So you have to draw a balance. That is number one. Number two is, we need to sort of look very deep into interplanetary missions, because now the thrust is given with all advanced spacefaring countries to go to various other planets, because it is strongly believed that resources available are plenty. Even asteroids, for example, plenty of resources available, and how do you mine, how do you get it? Of course, subject to formulating the proper rules and regulation policies, all that you need to do. But in order to do that, I think we also should be the very active player. Today, otherwise, only 3 countries are having the capability. We have just entered, but we need to do much more in both these areas. In my opinion, these are the two important areas next 8 to 10 years concentrate, in addition to whatever else that we have been doing for the country. And of course, the third, I think somebody had asked the question, we have done it for ourselves. But if we have to expand, how do we expand? What is the kind of resources? That is the third one. And fourth one, I would say that, we were working till now as only ISRO, sort of confined to our own house, our own domain. But then now we are opening up with the reforms that are announced by the government of India, and rightly so. We should do that. But in that environment, how do we really work together so that we keep the country's interest much more than our own individual interest? So the country should get the bit of that. But at the same time, the boundaries and barriers are to be very clearly defined so that we don't get into any kind of conflict. In the process, what happens, I tell you, is the competition very fierce. And when the competition becomes fierce, you need to improve your technology, you need to improve your quality, you need to improve your cost. I think that becomes really very difficult for all people who are involved. Any monopoly house cannot do that. So once you bring this kind of competition, we need to look at it. So these are the two, three areas, in my opinion, one should concentrate. And there is lot more one has to do, but then I would leave all these things to youngsters like you to come up with your own blueprint and then prescribe for that.
Definitely, sir. I think that is quite inspirational as well. And there are a number of challenges that we still have to ace to be able to accomplish greater things. There was one very common bit with the student questions that I would like to ask here. And I think that can be our concluding note. The question is, what was your inspiration to work for the country? And would you like to communicate any ideas that you have or the aspirations that you see the future generations fulfilling in your perspective?
From the childhood, I always believed I should do something for the country. That was a very, very strong belief. When I got my doctoral studies opening in UK, United Kingdom, Salford University, Manchester. In fact, many of our friends told you got an excellent chance and you can continue, you can do that, this, and all that. But then I was very, very clear: compete and come back and work for the country. There is nothing like contributing to your own country, and I very strongly sort of advocate to everybody. The days have changed. Today, I think the country has progressed quite well. It is for us to really contribute to the country and make our country great. And don't ever think that you can do wonders if you go elsewhere. Go, no doubt. Like I went for studies. You also go for studies. You also, if necessary, 1 or 2 years, you work and come back. Nothing like contributing to the country. The opportunities that are available in our own country, once you excel, limitless, which may or may not happen in some other countries. There are people who have really occupied the position, but then many times it won't be treated in the same way. And another thing I have experienced is that, it's okay if you are working in university or an organization. My own experience is that, yes, you are well respected. But same thing, you go into the public domain and they always look with tinted glass. You feel somewhat, you don't feel that happy. So my own feeling is that this is the time for us to take the country forward and make it as the super nation. This is what Kalam used to tell all the time. I 100% agree with him. We must make this country as the advanced nation and take it forward and come out with more and more innovative ideas. And before I want to conclude, I want to tell you one thing. I think you have to not just study what you have been told. I think you have to become looking with many, very many innovative ways of doing things. And whatever you do, come out with the innovation, and a country which innovates only will become the superpower in the coming years. And I think you all have a very, very bright future, very, very good weather and atmosphere. And I'm sure it's going to happen. And keep that in mind, but try to gain knowledge wherever you can, but come back and serve the country. I think that should not be forgotten. Don't fall after the money. Many times I have seen that people, when they even come for studies, sir, would I get the big job? What is salary I would get? I think all of us are in a country, we are very comfortable. As long as we excel, do well, I think there is nothing like that. What you should ask for is every day I should get good sleep, I think. That is very, very important. As long as you get the good sleep, I think you are very well contented and you can take care of yourselves, take care of your parents, take care of your society, take care of the state that you live in, and take care of the country. So with these viewers, let me convey my very best wishes to each one of you who have sort of taken trouble to attend and spend your time, and wish you all the very best. Thank you.
This was the finale of the first season of Zeroing In, the Science Podcast, in conversation with Dr. B. and Suresh. It has been brought to you by the Alumni Association of the Indian Institute of Space Science and Technology. Zeroing In aims at bridging the pronounced gap between the school students and academic mentors, science, technology, and research enthusiasts, and the graduate school academia and scientists across the country. We extend our sincere gratitude to Dr. B. and Suresh for sharing the singular gems of wisdom and a much coveted insider's view of the Indian Space Research Organization. And we are also grateful for the active participation from the students and the schools from across the country. On behalf of the Zeroing In team for this episode, which included Fenil Shah, Manish Chauhan, Shreya Mishra, Prajwal Patnaik, KVNG Vikram, Arun S., Ethan Fangcho, and Aman Naveen. And I am Naman Jain. Thanks a lot for listening to this episode. We'll be back with the second season very soon with further interesting questions and conversations with eminent scientists and researchers from across the country. If you have any suggestions, you can write to us on zeroingin@outlook.in or contact and follow us on our Instagram, Facebook, or YouTube handles at Zeroing In Podcast. We wish you a very happy and healthy interval until the next time.